Hi future doctors, welcome to the next class. In this class onwards, we will discuss about work energy and power. So in this mainly, first we will discuss about work. So when we can say work is said to be done. So always work is going to be done by some amount of force. When it is said to be done means when force is going to be applied on an object, the object should get some amount of displacement. Then we can say some amount of work is done. So its definition is going to be defined as F bar dot S bar. This is the example for scalar product also. F bar dot S bar. How we will write? Fs cos theta. Because already we came to know A bar dot B bar. We discussed AB cos theta. What is A here? Magnitude of A bar. What is B? Magnitude of B bar. What is theta? Angle between A bar and B bar. Here also same like that. F is magnitude of force. S is magnitude of displacement. Theta is angle between force and displacement. Let us assume this is an object of mass m. Some amount of force is going to be applied in this direction. Displacement is going to be moving in this direction. Then angle between these two is theta. Then how it is going to be defined means, if you resolve this force into two components, F cos theta, this is going to be F sin theta. Now work is going to be done by F cos theta because displacement is in the direction. Therefore, W equal to F cos theta into S. The product of one of the component of the force and displacement in that direction. So this one only we will write F bar dot S bar. Now what is theta here? Angle between force and displacement. What are the units for this? What is the force unit? Newton. What is the distance or displacement unit? Meter. Newton meter. So we can't write always Newton meter. That one only we are going to say lazy unit. What is the lazy unit of work means? Joules. If you want to write in CGS, force units, dynes. Displacement units, centimeters. So dyne centimeters. This one only we will call ergs. Now what is the dimension formula for work done? So force dimension formula ml power minus 2. Displacement L. Therefore ml square t power minus 2. This is the dimension formula for work done and definition of work done. Isn't it? So F bar dot S bar. How they are going to ask the questions on this? We are going to see. Once we came to know this equation, how they may ask the question means force and displacements. They will give two vectors. F bar is equal to 2i cap plus 3j cap. So this force is going to be displacing an object. So I cap plus j cap. Then what is the work done? They will ask. So work done is equal to F bar dot S bar. So 2 into 1 plus 3 into 1. So 5 joules. So already this dot product we have given in basics our class. Therefore each and every basic whichever you require, almost 80% we discuss in our basics. We have given almost basics of NEET 17 videos. In that one of the video is going to represent how to do dot product of two vectors. You can watch there. So if you want how we have done this question. Next, this displacement may be some one position to another position. How they will give this vector means force they will give like this. F bar is equal to 2i cap plus 3j cap. Then position of the object is changing from so 1 comma 1 comma 1 to 2 comma 3 comma 4 meters. So position of object is changing from 1 comma 1 comma 1 to 2 comma 3 comma 4. Then how we are going to do work done? W is equal to. So work done is scalar. So W is equal to F bar dot S bar. Now F bar dot. What is this S bar means? If you are assuming this is R1 bar, this is R2 bar. So here we will write R2 bar minus R1 bar. So now what is R1 bar here? R1 bar is I cap plus j cap plus k cap 1 1 1. So R2 bar 2I cap plus 3j cap plus 4k cap. Then what is R2 bar minus R1 bar? R2 bar minus R1 bar is equal to 2 minus 1. I cap plus 3 minus 1. 2j cap plus 4 minus 1. 3k cap. Then what is the work done formula according to this? W equal to F bar dot S bar. Now what is force? We have given 2I cap plus 3j cap dot. Now what is S bar we got now? S bar means R2 bar minus R1. I cap plus 2j cap plus 3k cap. So if you multiply, so 2 into 1, 2, 3 into 2 plus 6. Here there is no k cap here, therefore 0 k cap plus 0. Therefore 8 joules it is going to come, isn't it? So like this they may ask the questions. Next, for small displacements, if displacements are going to be small, then how this work done is going to be writing means dw equal to f bar dot dx bar or ds bar level. So dw is equal to f bar dot ds bar or f bar dot dr bar. So if you do integration on both sides, integral dx is x. So integral f bar dot ds bar. So during this time, how they may ask the questions. This is by maybe force is going to be variable. By variable force, if displacement is changing, how we are going to write this formula and how we are going to solve the problems. So F bar is equal to 2x I cap. F bar is equal to 2x I cap. Then how work done is going to be written. So general, so W is equal to, so integral 2x I cap. How ds bar is going to be written means dx I cap. At the time, how we are going to write 2x dx. They will give how x is going to be variable. X is going to be changing from x1 to x2. Then how we will do means just we will do integration x square by 2 between the limits x1 to x2. At the time you can cancel this. So x2 square minus x1 square. So this is the work done equation, isn't it? Now for the given problems, how they may give this? We will see one simple problem. F bar is equal to xi cap plus 2y j cap. Only I cap j cap we are taking. We can take k cap also, no problem. So this object is, by applying this much amount of force, an object is moved from one position to another position. So its displacement is going to be 2 I cap plus 3 j cap, isn't it? So they may give like this. Otherwise, they will give it is changing from 0 comma 0 comma 0 to 1 comma 2 comma 3. So in both the cases, how we are going to solve the problem, we are going to see. So in this work done, W is equal to F bar dot ds bar or dr bar. So after doing integration. Now what is F bar here? Xi cap plus 2y j cap. Now what is ds bar? So ds bar is nothing but dx I cap plus dy j cap plus, generally we will take like this, dz k cap. Then after doing or multiplying I cap x dx plus 2y dy. In this there is no k cap, therefore 0. Here x is changing from where to where? X is changing from 0 to 1. You have to do the limits. Y is changing from 0 to 2. Z is changing from 0 to 3, but there is no k cap is going to be present. Now again integration x square by 2 between the limits 0 and 1, 2. So integral y dy. So y square by 2 between the limits 0 to 2. So first we have to substitute upper limit. 1 square by 2 minus 0 square by 2. If these two cancel, 2 square minus 0 square. So in this you will get 1 by 2 plus, in this you will get 4. So 2 is LCM, so 1 plus 8. So 9 by 2, 4.5 joules. So they will give like this whenever they are going to ask the problems. So this is like integration method if position is going to be changing. So if they wanted to give 2x here, 3 means 6y. So again you have to do integration like this one. How you have done here? Like this. If it is changing, they will give between the limits. If it is not changing, directly we will do dot product and simply we will add. So this is about how they may ask the questions on work done. Next, still how they may ask means, already we discussed area under the graph, force and displacement graph they will give. So what is the area under this force and displacement graph? So it is going to be product of force and displacement. Therefore, area under force displacement graph gives work done. So generally they may give like this also. Next, when the work done will be 0. So when the work done will be 0. If applied force is 0, if you are not applying any force, then work done will be 0. If displacement is 0, you are applying force but displacement is 0. How you will get means, you are applying some amount of force on this board or a force on this wall, but this wall is not moving. Therefore, displacement is 0 even though force is applied, so work done is going to be 0. Now, if both are there, force is there, displacement is there, but even though work will be 0, when means if theta is going to be 90 degrees. 90 degrees means between force and displacement angle should be 90 degrees. If you are moving any object on the surface in right side direction, so displacement is right side, but gravitational force will be acting downwards. What is the work done by gravitational force on any object which is moving horizontally? So that is going to be, force means mg, displacement means s, but angle between force and displacement is 90 degrees. Cos 90 is 0. Therefore, work done is going to be 0. Can we get work done 0? They will ask. Yes, we can get 0 among these cases. Can we get work done negative? Can we get work done negative means? Yes, we may get. When means, if cos 180, if theta is going to be 180 degrees, what is cos 180 we discussed? Minus 1. See, all these we discussed in our basics class. Therefore, all the basics you will be getting in any point of view or at any lesson, at any equation. Cos 180 minus 1. Therefore, W equal to Fs cos 180 we should get. But where we will get angle between force and displacement 180. If you are applying force right side, so in frictional force what we discussed? Frictional force is going to be applied left side if object is moving right side. Now what is the work done by frictional force means angle between displacement and frictional force is going to be 180. Therefore, minus Fs. F is here frictional force. Work done can be 0, work done can be positive. When the work done will be maximum, work done is going to be maximum means if theta is going to be 0, means for both force and displacement, if they are going in same direction, cos 0 value 1, then work done is going to be maximum. So maybe on this also you may get the question when it will be 0, when it will be positive, when it will be negative. Work done can be negative also.